All right, guys, here's some examples over standard form to kind of help out. So there's a screenshot or a picture of the actual notes that we took. So this is standard form when x and y are together on the same side. Now here's the thing, we do not like standard form. It's terrible, okay? We want that good old y equals mx plus b. There's a reason they write songs about it. There's a reason it's so great, because y equals mx plus b has the information you need in order to graph. So if you don't have y equals mx plus b, then we need to isolate the y, okay? That's the first thing we've got to do to make this a graphable equation. So if I'm going to isolate y, remember back from the beginning of the year, I'm going to subtract 8x. I'm just moving things away from y to get it by itself. Those will cancel out. I end up with 2y equals negative 8 minus 8x. This is already kind of odd looking because I want mx in the front, but I can take care of that later. To isolate y, I'm going to divide by 2, and I end up with y equals, now, if you remember earlier in the year when we did literal equations, you were totally okay to leave your answer like this. Well, this does not show me a y-intercept and a slope. So now we're going to have to distribute. So negative 8 divided by 2 is negative 4. Negative 8x divided by 2 is negative 4x. And then just because I really do prefer mx plus b, I'm just going to rearrange this a little bit to say, okay, let's put the mx part in the front. Negative 4x is your slope with your x. And then negative 4, the y-intercept, I'm going to put at the back right there. Okay, this version is so nice because now if I was going to draw a graph of that, I could say, okay, my graph begins, again, if I'm thinking mx plus b, I'm going to begin on negative 4, so 1, 2, 3, 4. And then I'm going, well, you can't see that, and then I'm going to move negative 4 over 1. So I'm going to move from this dot down 1, 2, 3, 4, and over 1. Okay, I could continue it. I could go back up here to get the dot up here. But that information, that version of the equation, slope-intercept form, actually gives me graph information, which is super helpful. Okay, so if it's not in y equals mx plus b, we're just going to rearrange it like we have earlier in the year. So here, it's not in slope-intercept form. I'm going to isolate that y, so the first thing I'm going to do is add 2x to both sides. To cancel out a negative 2x, I'm going to go ahead and add 2x. I'm left with 5y equals, and now here's why I would highly recommend, instead of leaving it as 15 plus 2x, I'm going to put it already in this mx plus b format. So I'm going to say 2x plus 15. It's positive 2x, a positive 15, so I don't have any subtraction I have to keep track of or negatives. Now I'm going to divide by 5, and I end up with y equals 2 over 5. You can't actually do the division, and I don't really want to. I don't want to go to a decimal on this because I know that that's my slope that I'm getting right there. So I like to see a rise and a run. So if I can't work out 2 divided by 5, I'm just going to leave it as 2/5 with an x. For my y-intercept, 15 divided by 5 gives me a positive 3. And so again, I could graph this. Now I have mx plus b, so I could begin at 3 and move according to my slope. So it's just really taking stuff that we've done before, but now you actually have a reason why we're isolating y, because we like this mx plus b version. Over here, same thing, I'm isolating y, so I'm going to subtract 3x so that it cancels out. Don't forget that that negative is still there attached to the y. And then I'm going to go ahead and put this in the order that I want. So I'm going to go ahead and say negative 3x plus 12. Okay, notice I can put them in either order. Doesn't matter which one goes first as long as it's a positive 12 and a negative 3x. Now this one's a little bit different because you're dividing by a negative. So I'm going to have to really think about what's happening there. I end up with, okay, negative 3 over negative 4. I can't work out 3 divided by 4, so I'm going to leave it as 3/4. But sign-wise, I have a negative and another negative. So double negatives being divided leaves me with a positive 3/4 x. Then here, 12 divided by negative 4, well, a positive 12 divided by a negative 4 leaves me with a negative 3. Okay? This process, the same exact process of isolating the y if we're graphing, totally works in this situation with an inequality too. I can do the same exact steps. So if I'm isolating y, I'm going to subtract x first. So I'm left with 2y is less than negative x minus 14. Then I'm going to divide by 2. Notice if it's a positive, I don't have to write it. Really, I just need to be careful about those negatives. When I divide by 2 here, I end up with, well, let's see, negative x divided by 2. I know I can always put a 1 in front of a variable. Oh, so negative 1/2 x. And then negative 14 divided by 2 gives me negative 7. Oh, notice what I did. I made this mistake. I can pretend I did it on purpose, but I didn't. A lot of y'all do this. Your inequality suddenly changes to an equation. I want to be super mindful of the fact that that is an inequality because it changes my graphing a little bit. Okay, this graph, if I go back to mx plus b, I'm going to begin on negative 7. So I'm going to begin on 1, 2, 3, 4, 5, 6, negative 7 right there. Okay, and then my slope, I'm going to move negative 1/2. So I'm going to rise negative 1 and then run forward because we always run forward. That's going to give me an actual negative line there, down 1 over 2. Now, when you're graphing inequalities, remember you have to think about, is it a solid line that's going to be happening here, or is it a dotted line? Well, let's see. It doesn't say that it equals that. It's just less than. So I'm going to do as good of a dotted line as I can here without a ruler. Do a nice dotted or dashed for my people who don't like to use the phrase dotted. Then the other thing you've got to consider is the shading. Am I shading above this line or below this line? Well, let's see. It says y is less than my line. So I want to go on the y-axis, and I want to go everything less than the line, and that will kind of get my shading started, and then I just have to extend it. So be careful when you're graphing those inequalities. It's still mx plus b, but you have those extra little things you've got to think about, okay? All right, one more example. Another inequality, because inequalities do have one little tricky thing that happens in them. All right, I'm going to add 5x. Those cancel out. Negative 3y is greater than or equal to, I'm going to go ahead and put these in order, 5x plus 9. Put the x term in the front. Then I'm going to divide by negative 3. And here's where we test your memory. Remember, when you divide by a negative, that symbol has to flip around, okay? Anytime you divide by a negative, greater than becomes a less than. So y is now less than or equal to, let's see, 5x over negative 3 is just negative 5/3 x. It doesn't really matter if you move that negative up into the top. It's the same thing. As long as it's not double negatives, that's a different situation. And then at the back, 9 divided by negative 3 is negative 3. So I could put plus negative 3, or I can just do minus 3, okay? And then as far as graphing this one, I would have to be aware of the fact that it is going to be a nice solid line, so no dashed lines in there at all. And this one ends up being a less than as well, so I would shade underneath wherever that line is. It's not a horizontal line, okay? I just wrote that as an example, but it is not horizontal because it has a y and an x, all right? Okay, good luck. Hope this helped.